Hi, I'm Jonathan Oxer, and this is SuperHouse. If you're doing any sort of home automation project or industrial automation, pretty much anything where you want to control physical devices from a computer, a really useful building block can be a little device that has something like a network connection, like an Ethernet connection, and a series of switched outputs. That's exactly the sort of thing that I need for my home automation switchboard, so I'm going to put one together right now. I'll show you how easy it is. It's not as hard as you might think. The heart of this build is going to be the Ether 10, which is an Arduino-compatible board with built-in Ethernet. Just plug your network cable in, load up a program that talks via the network, and away you go. But it's only got these Arduino headers, which are good for logic level communications, but they're no good for switching external loads. So what I'm going to do is use a couple of these Relay 8 shields. What these do is use I2C communications to control a number of outputs. It's got FETs on here which switch the outputs, and you can supply power to it. So each of these 8 output channels can drive a relay, or a different kind of load if you like, but in my case I'm going to use relays. And because it's I2C and addressable, I can take a couple of them, stack them on top of each other, and now I've got 16 switchable outputs that can all be controlled by the Arduino. So if we power that up, plug it into the network, away we go. We can just plug this into the DIN rail mounted relays that are in my switchboard. You've probably seen that already. And we can turn things on and off. Now what I'm also going to do is power the Ether 10 via the network. You can power it by USB, or you can power it by the 2.1mm DC jack, but I'm going to use power over Ethernet. It's got some headers on here that allow us to extract the power that comes via the network cable and then feed it into the onboard voltage regulator. It's got a couple of headers on here, so we'll take these off, a couple of jumpers, and then we can fit either this PR28V, which is a 28 volt maximum DC input regulator. Basically it fits over here, we solder it onto the headers, and away you go. That's good if you're doing cheap DIY power over Ethernet, but I'm going to use a commercial power over Ethernet switch, so instead I'm going to use this Freetronics power over Ethernet regulator module, and it's got the same header configuration here. So it just goes into place on here. I need to solder it on, and then the Ether 10 will be able to accept up to 48 volts down the wire and will be powered via the LAN cable. And the output from this regulator module can also be passed through to the Relay 8s, so that can then be used to switch the relays. So we have power coming in via the network connection, down converted by this module, regulated for use on the board, and also made available for the externally connected devices. Now because I'm going to be putting this into a permanent installation, I'm going to the trouble of mounting it all in a nice box. So I've got this good case here which has got seals and all sorts of things, so it's going to be nice and secure in there. And rather than just run cables through holes and screw them into the screw terminals, I want to make this really easy to work with and easy to connect and disconnect. I've got a whole bunch of these RCA connectors from a previous project that I ended up scrapping, so I pulled them all back out again. And these are cheap and easy to work with, so what I'm going to do is mount a bunch of RCA connectors along the outside of this, and then I'll make up some cables, so patch cables that use these RCA plugs, plug into the side of the box, and then they run out to whatever load I want to switch. So what we've got here on the bench in front of us is pretty much everything that we need. In fact, we're not going to need that, so I'll put that aside. So really this is everything that we need, plus a couple of bits of wire, to build ourselves an internet connected load switching device. So let's get started by putting on the power over Ethernet regulator. The power over Ethernet regulator is now soldered in place. Soldered onto the headers on there, and it's got a couple of mounting stakes as well. But now we have a little bit of a problem. If you look at it from the side, you'll see that the regulator sticks up quite a long way. If we now take the Relay 8 shield and try to mount it on top, we've got a clearance problem. If you look down the end, you'll see the shield hasn't even gone into the headers and it's already sitting on top of the regulator. Now we can solve that very simply by using a couple of stacking headers as spacers. Because the Relay 8 only really needs the power connections and I2C, we don't need to fill all of the header slots. So what I'm going to do is just put in a 6-way header for here to make sure that I2C works. We'll put in an 8-way header for the power, and we'll put another one up the top just to give it some mechanical support. So now the Arduino headers have been raised a little bit, and now we can take one of these shields, fit it into the stacking headers, and it now sits down nice and firmly, but it gives nice clearance for the voltage regulator underneath. That's exactly what we want. And then we can take the second Relay 8 and stack it on top. But here we have a little bit of a problem, and that is with I2C pull-ups. I'll take all of this back off again, and all the way down to the bottom. This particular Ether 10, which is the current model, has a MAC address chip on it. It's this little chip right here, which is I2C. Now because it's I2C, there are two pull-up resistors. There's one here and one here. And they take the SCL and SDA lines and pull them up towards 5 volts. Now all I2C buses need a set of pull-up resistors. But the problem is we have pull-up resistors here on the main board, and we also have a set of pull-up resistors on each shield. In fact, just here and here are pull-up resistors. Now, if we have a look at what the value of that would be. So a typical pull-up resistor is 4.7K, and we have 3 of them in parallel. So for the really simplified version of the formula for resistors in parallel is you take the value of the resistor, which in this case is 4.7K, and divide it by the number of resistors, so 3. This is only, of course, if you've got all resistors the same value. This is just the simplified formula. And what we end up with is about 1.56 or so kilo ohms of pull-up resistance on the I2C bus. And that is a very strong pull-up. So we don't really want that. So what I'm going to do on these two shields is remove the pull-up resistors. Now when I was designing this shield, what I really should have done is thought ahead and made little cut track jumpers or something so that I could disable the pull-ups. Because part of the point of I2C is you want to be able to have different addressable devices and have them all on the same bus. And instead I just put the resistors directly on the bus. So I'll just get the trusty soldering iron, and I should be able to get those resistors off the board. There's one, and there we go. Now the pull-up resistors have been removed. I just need to make sure that there is no short across them, because of course that will be effectively a 0 ohm resistor. But what we have now are two shields that have been modified to have their resistors removed. Now, just so that I don't catch myself out later, if I come along years down the track, look at these and I forget that these have been removed, I'm just going to put little highlights on the PCBs here with a marker pen so that I know that those particular pull-ups have been removed. In fact, it would be sensible to even say pull-up removed. And that way I won't be confusing myself later. Now we can assemble this stack, and what we'll have is the Arduino board with its voltage regulator. We've got the onboard MAC address chip with its matching pull-up resistors for I2C. Now I need to put these stacking headers back in place. And we'll end up with a stack that allows us to control up to 16 outputs switched via the network. I almost forgot. I'm going to need to put an address jumper on one of these. So what I'll do is I'll leave the bottom one with no jumpers on the address pins, and I'll put a jumper across one of the address pins on the second one so that we can address the two shields independently. And that's it. So we could now plug that into a power over Ethernet network connection, and with the appropriate sketch loaded we could drive those outputs. But that's just the start of it, because what I want to do is mount all of this in a box. So what I need to do now is work out how I'm going to make all of this fit. I think the best thing to do is going to be to mount it this way in the box. The box itself will go onto the wall, so this is up, down, so it'll be mounted horizontally. And I want the Ethernet cable to be accessible externally, so I'm going to need to cut holes in the side of this box to match the Ethernet cable, the power jack and the USB connector, so that I can do firmware uploads while it's all in place. And then I can mount the RCA jacks on the other side of the box. I'll do a few rows of them here. And then with the lid on, it'll be a nice self-contained little unit. After a bunch of cutting and drilling, I now have the case all sorted, ready to go. I've got cutouts here and mounting holes in the bottom so that the Ether 10 will sit in place here. All of the ports are accessible on the outside, and I can run bolts and put a couple of spaces through to mount that in place. And across the top I've got the array here for all of these RCA sockets. Where's one? I thought I had one without the screw on, but maybe I'll put it back on. So all of these will fit in place along there. So I've got a total of 16 there, which will need hooking up on the inside. So now I've got to begin the monotonous process of mounting everything in place. I'm making some progress now. I have the Ether 10 mounted in the bottom of the box. It's firmly mounted in there. There are some plastic screws that go through, and there are 3mm standoffs that hold it off the base of the box, and we're going to get access to the ports. I've got all the RCA jacks in place. I've got flying leads all soldered in. So next I need to fit the Relay 8 shields in place and screw in all of those wires into these screw terminals. Now finally this is coming together. Everything is mounted in the box, and I have a USB cable here connected to my computer, so I can plug it in, power it up, and we can see now that there is power on the Arduino down at the bottom, and you can see there's power also on the shield. So what I can do now is load up some firmware onto this. First thing I need to do is extract the MAC address from the Arduino down the bottom, and I'm going to put a sticker on the box so that later on when I'm setting up DHCP profiles and things, I can tell this to come up on specific IP addresses or whatever. So that's a really handy thing to keep track of. So now I know what the MAC address is. I've printed up a sticker, put it on the cover of the box. I'll seal all this up. And now we know what the network address is. We can use that for DHCP profiles and that sort of thing. Now, the Relay 8 shield in here comes with an example sketch in the tutorial that lets you manually control the different outputs. So I'm just going to slide over to my laptop, hit upload, and now you should see, yep, you see the LEDs flickering in there. So the new software is just loaded onto the Arduino. And now if I open the serial console, I should be able to turn different outputs on manually. Yep, there's channel 2, channel 3, go for channel 8, channel 4, turn them all off. Yep, so we now have control over the outputs, which are wired through to these connectors. So apart from the software to talk via the network, we're pretty much done. This hardware is ready to go. Because I already had these leftover RCA connectors, I'm using those to make up some cables, and also happen to have this big roll of security cables, so I'm just using that and connecting one of these RCA connectors on the end, mark it up, so this is one, and then I'll just pull off as much cable as I need, cut it, make another one. So this way I'll end up with a bunch of flying leads that have the RCA plugs on one end and just a loose end on the other. Then I can install it inside the switchboard or wherever it needs to go, terminate the other end after cutting it to the appropriate length, and we're golden. So let's load some software onto the device. I won't go through this software in great detail. I'm going to put all the source code online, and there are quite a few comments, so if you're really interested you can go through it in detail. But what I've done is combined the example code that addresses the relay shield and also provides a web server. So we include the web server library here. We need Ethernet for the network connection. We define the address of the shields, and it's got some options here for using DHCP or statically defined addresses. So we have the control box here. I have a USB lead which is connected to my computer, so I'll plug that in. It's just powered up, and now up in the tools I'll select Arduino Uno, select the serial port, and now we'll click upload. So it's now compiling, and you may just see some flickering LEDs in there. So it's uploading the sketch, and it's done. So we now have firmware loaded onto this box, and by opening the serial monitor, which I will bring over here so that you can see it, it says SuperHouse.tv output controller starting up, version 1.0, 16 channel. It's got 2 shields, getting MAC address from ROM, and it's showing what the MAC address is. There's no IP address shown. That's because I haven't yet plugged in a network cable. So let's do that. This network cable is connected to a power over Ethernet switch. So I plug that in, and it's now just got an IP address. My IP address is 192.168.1.165, and it says ready. So we can now load this from up in the web interface. And because we have this IP address, I can just copy that IP address, come over here into the web browser, add control onto the end of the URL, and we've now loaded up the web interface that is being served off this box. Now if I click, for example, output 9, you can see output 9 is turned on. Output 11 turns on. I can turn 9 off, turn 11 off. So I now have control over all of the different channels on the board just through the web browser. And we're done. We now have a nice rugged box. It's all self-contained. It's socketed everywhere, so we don't have any leads hanging off it. We can plug it into a network, have it power up, load a web page served off the box, and switch outputs. Fantastic general purpose device. It's a really cool sort of thing to build if you're into home automation or any kind of industrial control, that sort of thing. There are lots of enhancements that we could do to this. For example, we could add a hardware watchdog timer. I might cover that in the future. We could also do things like link it up to an MQTT server. So we'll probably revisit this in a future episode. In the meantime, I hope you've enjoyed it. Now go and build something cool.